sources are dominant, okay, of comparative advantage. Is it clear? That's why you have to distinguish these two. Okay. Now, in general, the evidence is mixed, and I'm going to show you now some results, because clearly it depends on different circumstances. Okay. In general, therefore, the evidence is mixed, and I'm going to now discuss some of the cases. Is it clear what I'm going to do is? So let me repeat this. I'm going to check the importance of environmental policy for determining trade flows, and here we have, this is called, therefore, the pollution haven effect. Okay, so try to see whether environmental policy affects trade flows, and this is called pollution haven effect. If it dominates traditional sources, then we have pollution haven hypothesis. Okay, this is what we're going to do now by reviewing some recent papers. Okay, so starting with this first one. Okay, they're in no particular order. Okay, so. So this is a recent still working paper that looks into sources of comparative advantage in polluting industries. And the question is the following, the research question. Okay, here I try to spell out the research question such that it's clear, okay, what these papers try to do. Okay, the research question is here, determine existence and strength of environmental regulation as a source of comparative advantage. So the pollution tries to assess the pollution haven effect. Okay. And in particular, does tightening environmental regulation lead to a relocation of polluting industries to countries with laxer regulation? And moreover, the paper also looks, even though I'm not going to report on this, but this is because of how the paper identifies variables. Okay, so that's how the estimations are done. How the paper estimates variables. What the paper looks also into is if how pollution emissions were dispersed in the environment due to meteorological conditions. Okay, so it looks also into this. It goes together with the identification strategy. So again, why is this important? Because of, well, it's quite clear, quite obvious. Lax environmental regulation can impose substantial health effects, health costs, therefore. The effectiveness of reducing greenhouse gas emissions, and also the extent to which trade policy can be, environmental policy can be used as a trade policy instrument. These are things that we are more or less already seen. Now let me go into a little bit in how this is done, even though, again, I won't go into the details. Okay, of what the paper exactly does. Okay, so what are the data here? The data are environmental policy at country level, and therefore they are taken from the Environmental Protection Agency, and the pollution intensity at industry level. And the data here in particular, they're not only for carbon monoxide here in this case, but also for nitrogen oxide and sulfur dioxide. Okay, so not only they do not only look at one pollutant, but more than one pollutant. So therefore, you have here panel data cross country, cross industry concerning here U.S. Manufacturing industries in 2005. Okay, so what the paper in particular does is it looks at relative import shares, okay, in a given industry as a function of the drivers, the possible drivers of a comparative advantage. If I'm going too fast, just let me know. Okay, otherwise. So what are the possible drivers of trade flows? And therefore here One is environmental regulation, the other is physical and human capital endowments, and they're clear in their intensity. And therefore, what they do is they look at emissions, capital and skill intensity. Okay, therefore, what they do is they regress, try to estimate, therefore, the importance of these explanatory variables, that is, environmental policy, endowments in physical and human capital, as the importance in driving the import shares. Okay? And therefore, should explain the comparative advantage of the country. So, what are the findings? The findings are countries with laxer environmental regulation have a comparative advantage in polluting industries. And in particular here, this is kind of interesting. The environmental regulation is compared in terms of magnitude, okay, in terms of importance. Is comparable to the effect of physical and human capital. Okay? So therefore, the magnitude of environmental regulation is comparable with physical and human capital. Okay. And this is a kind of support of the pollution haven hypothesis. It is a kind of support of pollution haven hypothesis. So therefore, the coefficients, the estimates are in terms of magnitude comparable to classical, to the more traditional sources, okay, of drivers of trade flows. Now another paper here. This is quite recent. This is forthcoming in economic policy. Looks at where do multinational firms emit, in particular here, this paper only looks at CO2, okay, emissions. Now the research question here, therefore, is the following. So how do multinational firms allocate polluting activities around the globe in response to environmental policy? Now, what this paper, I mean, the data here are quite different, because the paper, the paper looks at data taken from the Carbon Disclosure Project, which is self-reported responses of firms about their CO2 emissions, and the data set is a panel data set and covers large public firms headquartered in 48 countries and their emissions in CO2 emissions in 218 countries over the time period 2008 and 2015. And then also they have the strictness of environmental law and enforcement at the country year level, taken from the World Economic Forum. This is a biannual basis for 450 countries over the same time period. Now, what is the finding here in this case is the following. So firms headquartered in countries with strict environmental policies perform their polluting activities abroad in countries with relatively weaker policy. Okay, therefore, and here the authors conclude that it is the tightening of environmental policy that leads firms to pollute abroad. It's tightening at home that leads firms to pollute more abroad. And in particular, here are some estimates, okay, to have an idea. One standard deviation increase in the strictness of environmental policy at home leads to a reduction of 29% of emissions at home, up to 43% increase in emissions abroad. And this here is evidence of carbon leakage. Okay, this is carbon leakage. And overall, we observe a 40% decline in CO2 emissions. Moreover, what the authors find is that the distance in policy strictness predicts whether and the extent to which CO2 exporting of CO2 takes into account. Okay, so the distance between strictness of environmental policy, and therefore, again, the authors conclude that this is in support of the pollution haven hypothesis. Okay, so that is to say that environmental regulation is a major driver of comparative advantage and therefore of trade flows. Yeah, let me skip this. Perhaps it's less important. Let's move to another paper. This is a recent paper published in the American Economic Review 2018, and it looks at the empirical evidence that pollution in the manufacturing in the U.S. manufacturing industry is declining over time, and therefore, what the authors try to assess is the relevance of environmental policy and environmental regulation for this, and also the importance of productivity and trade. And the period they look at is the period from 1990 to 2008, and here the interesting thing is that the observation is that air pollution declined, so air pollution declined over this time period, but there was a substantial increase in manufacturing growth. Sorry, there's a type. Sorry, there's a typo. Yeah, there are many typos. Okay, sorry. Please do not look at my spelling. Okay, unfortunately, they're kind of writing fast and not revising what I've written. Okay, and not going over the. Not using the spelling automatic spelling feature, which would be very simple, but not doing so. Okay, here are the data. Okay, so this is you see here. This is the stylized fact. Authors here look at. I hope you can read this. Okay, this is so the blue continuous line is real output. Okay, and you see this is the empirical evidence. So you have. From the 90s to 2008, you have an increase in real output, manufacturing industry. But at the same time, you see you have a decline of major pollutants. So again, this is carbon monoxide, sulfur, nitrogen oxide, and sulfur dioxide, and volatile organic compounds also, and also particular matter, small particles. Okay, so it's a major pollutants that the authors look at, and the stylized effect, okay, is always the same. Okay, so you see a decline over this time period in pollution. Okay, and therefore. What here the authors try to do is they try to see whether this is due to environmental regulation. Okay, this is okay, here, what are the possible explanations? International trade. But with using the same inputs, you can produce more output. And if you have a sufficiently strong productivity growth, this also could explain why you have, on the one side, increasing real output, on the other side, stagnant or even falling inputs. This is compatible with a strong productivity increase. Okay? And therefore, what here the authors try to do is they try to decompose the result in terms, so that the observation in terms of scale of output, so the scale effect, the composition effect, and the technique effect. Okay, so remember what we have seen last week. Okay, so you can decompose pollution, the growth in pollution into a scale effect, composition effect. Different compared with other studies is that the authors here use product level data and not industry level data. So they really look into the micro data rather than more aggregate data. So physical products rather than industries, which has been done in previous works. Okay, so this is kind of peculiar to this study. Okay. And what is the main finding here? The main finding is that the scale and composition cannot explain trends in pollution emissions for the period. Okay, so the driver here is not, the main driver is not scale, the scale effect or the technique effect. Sorry, the scale or the composition effect. So remember, the scale is the fact that output grows. If output grows, then you have the input grow. Okay? This is the scale. Composition is what is produced in the economy. Is more dirty or more clean products. So therefore, the authors find that the scale and the composition effect, you cannot explain reduction in pollution that is observed in the data, and therefore this is not in support, the result is not in support of pollution-haven hypothesis. And here what they find, therefore, is that the reduction in emission is mainly due to a technique effect. Okay? So it is mainly due to a technique effect. So the pollution intensity is that changed over this time period. Here, this is the observed and counterfactor trends in this case. Okay, so here you see the scale is the green one, the continuous one. Okay, then the dashed red line is scale and composition, which again does not match what we observe in the data. And here you see the scale, composition, and technique effect is the dashed dotted blue line that is declining. Okay, the last one. Okay, and therefore this matches the observed data. Okay. Here, how is this done? Okay, how do the authors derive this result? They build a model and estimate the model, and in this way they obtain the counterfactors. Okay. The problem is always how to obtain a counterfactor. Okay, and therefore what they do is they build and estimate the model in order to determine the driver of the decline in emissions. And what they do then is they hit the model with different shocks in order to isolate the scale, the composition, and the technique effect. Okay, and so so in this way they simulate the counterfactors. So therefore, here the conclusion of the authors is that stricter environmental regulation led to an induced technique effect. Okay, so it did not affect much the scale or the composition, in particular the composition. That's why this paper is not in support of the pollution haven hypothesis, okay? Because they did not find strong evidence for change in the composition. And yeah, the shadow price of pollution doubled. They also found that the shadow price of pollution doubled over the time period for most pollutant, but not for CO2, because CO2 is not part of the Clean Air Act. Okay. So this really, so the idea here is that for regulation increased the shadow price of emissions, and therefore what firms therefore did is that they changed production technique. Okay, it's like if you remember the picture I've drawn about, I mean, a couple of weeks ago already, I guess. Choice of production technique depends on relative prices. Okay, here therefore what happened according to the authors is that regulation doubled the price of emissions. Okay? And therefore, by doubling the price of emission, this induced a change in production technique. And therefore, this led to a decline in emission. So this is what the authors estimate. Is it clear? So this is in keeping what we have seen a couple of weeks ago. So remember, you choose your production technique, having an isoquant and isocost function. If you remember, isocost function is, depends on the relative price of inputs. By changing, therefore, regulation, what you have is, in this case, the authors observed a doubling of the price of emissions, and therefore this led to a decline in emissions. Okay, is it clear? In keeping with what we have seen. Here again, this is it's just a little bit more of, yeah, it looks into the data, okay, how the estimate, how the model is, yeah, you can't see this really. How counterfactual emissions are obtained by shocking the economy. Okay. Here you see the shocks they have is so actual data are blue line. Okay. These are the different pollutants they look at. Okay, I mentioned before. So the blue line is the blue continuous line is the actual data. They are the actual data. And the others are different shocks. Okay. In particular, here you have a foreign competitiveness shock only, US competitiveness shock, okay, and regulation shock and expenditure share shocks. Okay, so this would simulate the different sources of different sources of emissions, so whether scale, composition, or technique. Okay, and here, therefore, what the authors find. Okay, you see you most likely can't see it, but the data that fit best are here the US regulation shocks only. Okay, and these are the one closest to the blue line. It will be the one closest to the blue line. Yeah, if you have the slides, you can see it. Otherwise, it's important. You can't really see it. Sorry. Okay. 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 Last paper I'm going to discuss here. Last paper here is about developing country. Okay, nice. Yeah, it's the paper that looks at India. Okay, and in particular here you see the question is whether foreign demand drives CO2 emissions. And here, what the authors do is they look at the firm level data, okay, in India. And this is a recent paper published in the Journal of Development Economics. And therefore, the research question is the following. So, does the increase, I'm going to show you in a minute, the increase in export flows from developing countries lead to an increase in emissions? Okay, this is the question. Okay, here. So let me give you some background. Okay, in order to understand what the authors here do is they study Indian manufacturing firms, and what they try to do is they try to estimate how firms adjust production in response to demand shocks, to demand increases. Here, this is particularly interesting for India because in 2016, India was the third largest emitter of CO2, 7% of global emissions, right behind China, which was 29% of world emissions. And large part of growth in emission, this at least is the claim here, is due to the rapid expansion in manufacturing output. Okay, so the strong growth in manufacturing output, and this is because exports. Okay, so you see the demand of developed countries, okay, of manufacturing goods from India, okay, led to a rapid and strong growth of manufacturing industry in India. And here the question is whether this was a driver of this strong increase in CO2 emissions. Okay, this is what the authors here try to real output. 2011 grew by about 310%. Okay. So a huge increase in manufacturing output. And over this period, CO2 emissions, yeah, I'll write it differently. Okay, that would probably be also once I got it right. Okay, and unregulated over this time period. And here the assumption is that this strong increase in manufacturing output is due to exports. Okay, so because there was a 658% over the same time period. Okay, so what are the data? Okay, the data are the following. The data set of large, yeah, sorry, it's full of typos. I will for sure review it. Okay, I'm very sorry for this. Indian firms compiled by the Center of Monitoring the Indian Economy. Okay, this is the data set. And what they do is the CO2 emissions are calculated multiplying energy consumption by source-specific CO2 emissions, and then sum over energy types. Okay, so this is a quite classical way to obtain CO2 emissions. Okay, so so you look at the energy source, and in this way you calculate CO2 emissions. What are the findings? The finding is the following. Output growth led to a very strong increase in CO2 emissions. which is because of the scale effect. So there's a scale effect. But then what the authors also found is that there was a strong mitigating effect because of a change in production technique. Okay. Now here this is kind of strange because there was no environmental regulation in place, okay, over this time period. So CO2 emission, as I mentioned before, was not regulated. Okay, and therefore one might wonder why this might be the case. Okay, and this is therefore another thing the authors looked into. And overall here, going back to this result here, overall CO2 emissions, they are positively related, but not statistically significant. Okay. So the growth is not statistically significant because of this strong mitigating effect of technique effect. Okay. So the output, so there is a positive relationship between output and growth and CO2 emission growth, but it's not statistically significant. And here the main reason is because of this is at least the claim, because of strong technique effect, and this is a mitigating effect. Now, by going back to the technique effect, as I mentioned, this is a kind of strange because no regulation was in place. And here the authors, because remember what the technique effect means. The technique effect means that firms change production technique. Okay, they switch kind of to cleaner, okay, production technique at the same time as there was this strong increase in demand. Okay, so you see on the one side you have this strong increase in demand, and at the same time what firms did is not simply increasing production as it was using existing production techniques, but they changed production techniques, switching to less intensively emitting production techniques. And here the authors conclude that what Indian firms did is they upgraded their technology, and moved from dirtier to cleaner production technique. And this was possible simply because they were very far away from. If you want to close also the other, yeah, it's really annoying. Let's just keep the. Okay, you can close if you want all the. Yes, really annoying. If you want, you can close as well. This way, perhaps we can. Okay, it's much better. Okay. Sorry for this. Okay, in this way, okay, you see what happened is because of this strong growth, okay, in demand, what firms did is they upgraded their technology, and this was possible at a relatively low cost because they were very far away from technology frontier. Okay, so Indian firms were very far away from technology frontier, and so it was quite cheap to upgrade their technology. And also what they did is they changed the production mix. Okay, if there was a multi-product setup towards lower marginal cost products with lower emission intensity. Okay, this was done, okay, without environmental policy in place to tackle the issue. Okay, it's just that this was done by firms, okay, without regulation. Okay. Okay, there are many other stuff. Okay, this is still a very active research area. So there are many other research papers that look into this issue. And again, therefore, for those of you interested in, okay, there's broad literature. And these are just some of the papers that I found interesting that quite nicely fit into what we have seen, okay, to give you some idea of what is done from an empirical point of view, okay, not just the theoretical point of view, but also what you could try to do, and just to stimulate some food for thought, okay, just to stimulate some thinking on your part, okay, if you are interested in these issues from a more practical point of view, which is, I guess, very important, more important. Okay, any questions on this part? Everything clear? Okay, so if there are no questions, so what I would like to do now is I would like to close here everything, to give a closure, let's say, to what we have seen here by addressing a final issue, and that is how to choose environmental policy. Because from now up until now, we have only seen what the effects of environmental policy are, in particular on trade flows, which is what we have seen right now, and also on another particular issue that was the carbon leakage. Okay, these are the two issues that we have seen also from an empirical point of view, not only from a theoretical point of view. Okay, but now there's still an issue that remains, and that remains to discuss. Okay, so how is environmental policy chosen? Okay, and here some of this discussion, okay, you already had in the first part of this course, okay, where you had international environmental agreements, the difficulties that arise in finding agreements, okay, collaborating. Here, what I would like to do is I would like to give you a little insight, okay, in why this might happen. Okay, what are the difficulties in obtaining, in coming to an agreement? Because countries, and this is what I'm going to do here, have an incentive if they are selfish, okay, so if they are self-interested, okay, they would like to give a competitive advantage to their country, or to their firms, okay, to the country as a whole, and therefore there might be an incentive to go in the opposite direction, okay, so not participating in environmental agreements, because in this way firms obtain a competitive advantage. Okay? So therefore, what we are going to see here is the theoretical counterpart of this. So firms, by reducing environmental regulation, gain grant competitive advantage to their firms, but the problem is the following: if everybody behaves strategically, then this might lead to a race to the bottom. Okay? So everybody tries to protect or favor their national champions, but by reducing environmental taxes or by implementing a laxer environmental regulation, but this has a problem that this might lead to a race to the bottom if everybody behaves in this way. Okay, so, and this is what we're going to see here. And what I'm going to do here is I'm going to review this quite old model. I think, again, it's useful because you have, again, a heterogeneous background. And so some of you are familiar with economics and duopoly theory, some of you might not. And again, this gives me the opportunity to somehow, again, level the playing field. And so here what I'm going to do is I'm going to show you a two-stage duopoly model where firms at one stage compete, and they're going to compete in quantities. Quantities produced, but quantities produced, they clearly depend on environmental regulation in place. Okay. And then So in one stage, firm compete, and in another stage, if environmental policies chosen either strategically or non-strategically. Okay, therefore this is going to be a two-stage model, where in the first stage, so the first mover advantage is to the environmental policy. Okay, so the policymaker has to choose the environmental policy, and in the second stage, given environmental policy, firms then compete. Okay, and therefore what I'm going to do is I'm going to solve this model, and the aim, let me repeat, the aim is to show you that there is an incentive for policymakers, if they behave in a strategic way, to reduce environmental regulation, and this might therefore lead at the world level to a race to the bottom. So everybody tries to reduce environmental regulation in order to promote, to help national champions, okay, in the international trade game. Is it clear? So the model is going to be very simple for those of you who are familiar with oligopoly theory. For the others, I try to explain things as simple as possible. And this is called ecological dumping. Okay, this is called ecological dumping. Okay, everybody, everything clear? No questions? So if something is not clear, okay, particularly if you are not, if you do not have an economics background, just let me know. Okay. Otherwise, I assume that it's things that you have already seen or it's clear. Okay, so let me go over there for the details of the model, the hypothesis, and then I'm going to show you the model. I'm going to show you the model formally, and I'm going to going to give you some intuition just by looking at some figures I'm going to draw. Okay, and it should be quite simple. Now, what are here the assumptions? The assumptions are the following. Okay, these are simplifying assumptions in order to get clear-cut results. I'm going to now explain why you need this in order to get a clear-cut result, and what would change if you would not have these assumptions in place in the model. Okay, so no transboundary pollution flows. No transboundary pollution flows here clearly simplifies the analysis, okay, because in this way, the policymaker is concerned about pollution, the effects of pollution at home, okay. The second assumption is even more important for the model, and that is consumers are located in a third country. Okay, so you have to assume like, okay, there are two countries that produce the output. Production is, of course, by polluting the environment. Okay, and what you have is you have competition between these two countries in terms of production. Okay, and therefore, the more they produce, the more the environment gets polluted. Here, the assumption is that consumption, of course, in a third country. Why is this the case? Because in this way, you see the environmental regulation is going to affect the competition game. Okay? Environmental regulation is going to affect the competition game, and the competition game clearly has an effect on consumers. Okay? So in particular, the stronger competition is, the lower prices will be. Okay? And therefore, consumers benefit from lower prices, and this will increase consumer welfare. And in this way, you would get, from a social welfare point of view, mixed results. Okay, and that's why, because on the one side, okay, let me give you an idea. Okay, so I try to reduce environmental regulation as a country, because in this way I'm promoting my firm. Okay, my firm has lower production costs and therefore can produce more. but in this way pollutes more. Okay, therefore this is negative for the environment. But so therefore you have on the one side the negative because of a more polluted environment. But if we had also consumers in this country, consumers would benefit from stronger competition and lower prices. And therefore you would have a contrasting effect. So more polluted environment, but low prices. Okay, and therefore, from a social point of view, you would not. I mean, it would be difficult to now to distinguish these two. Okay, so to say what is better or not. Okay, that's why consumers are placed in a third country, because in this way, the only thing that matters here is firms and pollution. Okay, even though we should also take into account consumers that would benefit from stronger competition. Okay? But since I want only to focus on pollution and the competition game, I'm kind of excluding consumers. Is it clear? Okay. I go back. Let's say I go back to this once I've explained the model. Okay, and I'm going once I've solved the model, it becomes quite clear. Okay, why I need this. Okay, but I just wanted here to explain why. Okay. For those of you who are familiar with oligopoly theory, I guess they got the point. Otherwise, I'll explain it more carefully once I have the result. Okay, okay, so now two countries, again, things as simple as possible. I have X, which is output of the domestic firm, Y, which is the output of foreign firm, and then I have E, which are emission permits, okay, emission permit. And we're going to see the effect of this in a minute. Then you have revenues, the revenue function. Revenue function is R, which depends on X and Y. So why does R depend on X and Y? R depends on X and Y. Why is this the case? This is for the home country. Okay, I'm only explaining here my home country, what happens to the home country, because then in a similar way I'll have the other country. Okay, so once I know how the home country behaves, by assuming that the foreign country is symmetric, I know what the equilibrium will be. Okay. So that's why everything here is are my home revenue. So Py is negative. Okay, suppose, now let's make things simple. Okay, so suppose you have P, which is 1 minus X minus Y. Okay, suppose you have a demand function like this here. Okay, then you see what revenues are. Revenues X, oops. costs. Yeah, by the way, okay, so I'm spending some time here on the model, okay, so on the model assumption, because remember, if you have a theoretical model, the results you get from a theoretical model strictly depend on the assumptions you make. Okay, so it's not that the results in a theoretical model are just magic, okay, they strictly depend on the assumption you make. Okay? By changing the assumptions, you change the result. Okay? That's why you have to be sure that the result, the assumptions you make sense. Okay? And then the other thing you clearly would like to check also is how robust your results are in changing the assumption. Okay? If your results just change marginally, or they change but not in a relevant way, then okay, who cares about the assumption? This was about the first two. But then the others here I'm making, okay, they make kind of sense. Okay? This is what you would like to expect, okay, to cost functions to behave or revenue functions to behave. Okay, that's why this is a quite simple but very few assumptions, but therefore quite robust results. Last but not least, what here is assumed is that you have a domestic environmental damage function. Okay, so here, by polluting the environment, you damage the environment, and therefore you have lower welfare. Okay, that's captured here by this VE function. Okay, and again, this is increasing and convex in E. Okay, so therefore the larger emissions are, that means the laxer the environmental regulation is, the more polluted the environment is, the greater the damages to the environment and to society. Okay, so here we don't have consumer welfare, and therefore bad done to consumer welfare, but it's captured by this environmental damage funds in a reduced form way, because we don't have consumers here. Okay. Questions so far? Everything clear? Okay, so if there are no questions, I would like to stop here, and after the break, I'm going to solve the model. I'm going to show you what the solution is and discuss the solution of the model. I will do it both analytically and some figures. Okay, have a nice lunch and talk to you if you want later. Bye-bye.
Però c'è sempre meglio avere anche solo poche al giorno per studiare stretto che ma dici che il caso le vogliamo ciao Carlo ciao Bea sì arrivo subito. Pensare questo. No, sì. Di solito quella è la più importante. Io voglio io mi sono trovato lo porterò dai mancati sotto casa express pensa sempre non è che c'è l'acqua oggi. Finché poi questo per un po' di storia della musica. Devo trovare per parlare questo modo di andare a
Oh, you said these pink ones. When you follow away. Oh, that's a third Polish.
E non ne voglio dire
Responsabile. Sono responsabilizzato. La strada.
Noi per costruire continuare quello lascio da mangiare che viene sì, ma poi quando ti serve io sto sempre non ha allora so bene io non posso dire però cioè appunto rimane comunque penso all'università poi da domani sono altri cioè piuttosto vai a casa e piuttosto vai a casa e torni. Ma mi faresti un'ora libera. Poi non so, che ne so, non mi sveglio anch'io. Sta Chantal. Ce ne sta Chantal. Chantal. Boh, bene, un po' che non l'ha detto. Allora lì non mi chiama mai, perché sempre io. Poi mi desideravo che sapeva come sapere. 4 mesi dopo, cosa succede? Io alcune prove devo screenshotare per sottoporre forza, vedi, sei del strings. Poi li tolgo. Ci non servono. Beh, sì, serve per fornire, serve per fornire, però
capire, non capisco se
Io ho capito.
io guarda, assegnata allo studio.
Grazie.
Io guarda, sicuramente se
Difficile.
io sono una bimba di gatto.
Sei una bimba di casa.
Minchia.
Aspetta, sempre in centro.
Quando anni lo dici?
Cioè, senza di me.
No.
Vabbè, hai esaminato, non è che non è
Esatto. Tanto ormai sono simile.
No, io non sapevo questa roba.
C. Però si deve fare, se sbaglia,
No, non è sbagliato.
ma perché per la mia strada no, è sempre stata la distanza più di Firenze. È sempre più neve, dove per lui anche più di se stesso, diciamo. E secondo me si guardano con lo specchio, non riesce a stare bene con persone. I suoi amici, pure non so che ci sta male, quindi è veramente sempre, cioè quando già siamo lontani, se poi non è anche voglia di fare parli, di dire, che non si è lasciati a malincuore tutti e due, con dispiacere, però chissà, che può fare.
Chiudono in questo momento, però.
Sì, esatto.
Va bene, che però cioè,
Sì,
un po' una.
esatto, un po' amaro, perché a me non piace tanto, mi dispiace che fosse sempre alcune dinamiche strane, cominciano a stare male perché e lui mi faceva stare male, farmi stare male, era un po' tricky, sì.
Vabbè, spero per voi.
Grazie. Però sì, stavo vedendo tutte le però io mi sono abituata. Allora questo quando si incubava avremmo rimandato. Si diceva, c'era un'amica che mi aveva detto che quest'estate fa il concerto del Rimini con una delle sue amiche e avete detto soldato, se per caso qualcuna si ritira te lo dico subito, no? Esatto. Ciao, sono prima, piano delle slide. Come si grava? No,
Fossero così fatti, ragazzi, dentro l'idea.
Io ce l'ho.
È vero, ci sono
Per fortuna, da una parte.
non basta invece.
Vabbè, ma tanto è una cosa molto Esatto.
Ma sì, non so. Era ritorno dal ritorno, ritorno. No, servire. Esatto, questo è non è
Io invece il cammino, prima della sfida del dolore, un nuovo sotto casa. La prima sera finalmente questi droni, questi danni,
i botti, i botti, i botti.
Vabbè, siamo fatti anche questa esperienza.
Ciao, ciao, era più da
Okay, so let's start. Any questions before starting? Everything clear? Okay. Okay, now let's see how this model is solved. Okay, so this is a two-stage game. Okay, so there are two stages. Remember, in the first stage, the policymaker chooses the emission cap. Okay, so chooses emissions. In the second stage, we have the competition game between firms. Okay, so how are we going to solve the model? Since it's a two-stage game, we are going to first solve the second stage, and then we are going to solve the first stage. Okay, and I'm going to explain to you why this is the case in a minute. Okay, but first of all, okay, I'm focusing just on stage 2 of the game. So we're going to calculate what is called the Nash equilibrium in the second stage, and then I'm going to calculate the overall equilibrium by solving the first stage model. Okay, but first things first. Okay, so let's focus on the second stage game. Okay, so let's see. Let's use the nodes, and then if something not clear, I'm going to perhaps also add something to it. Okay, so what is the second stage? So in the second stage, first of all, so the only thing I have to consider here for the moment being are firm profits. Okay, so I have to see how the firms optimally choose the quantity to produce, and how do they do? Firms choose optimally X. So my home firms, okay, choose optimally X by assuming that Y remains constant. So in this case, what you obtain is what's called a best reply function. So that is how I behave given the environmental standard and given what my competitor does. I obtain the optimal production. Okay. And this is not a scalar, but it's a function, because for each action of my competitor, I have an optimal reaction of my home firm. And therefore, I have a best response function. And then the equilibrium in the best response function gives you the Nash equilibrium. Familiar with this? Everybody's familiar with the Nash equilibrium in continuous strategies? Yes. Okay. Okay, so let's see how this is done here. Okay, so profits are therefore revenues minus production costs and minus abatement costs. So therefore, what I have to do is I have to maximize profits choosing X and taking E and Y as given. Okay, because in this way, what you get best response function. Okay, so given what the policymaker has chosen and given what my competitor does, I define what's optimal for me to produce. Okay, so therefore the first order condition is pi x equals 0. So the derivative of pi with respect to x equals 0, and this therefore gives you Rx minus Cx minus Ax equals 0. Okay, so marginal revenues minus marginal costs, production costs minus marginal abatement costs equals 0. Okay. From an economic point of view, should be quite clear. Okay, increasing X by a unit gives you additional revenues, additional production costs, and additional abatement costs. And what I would like to do is, I would like that marginal revenues equal marginal costs. Okay, this gives you the optimal production. Okay, from intuitive. So Rx is our additional revenues have therefore to be equal to additional costs. Okay, this gives you the optimal strategy, firm strategy. As I mentioned before, this does not lead to a scalar, so that is a number, but gives you a function, because X depends now on what my competitor does and what the policymaker has chosen. Okay, therefore here you have a reaction function. Okay, so my optimal response, given the action of my competitor and given environmental policy chosen by the policymaker. Okay, this is therefore a reaction function. What one can here calculate, and here I have the calculus on the notes. Okay. I don't have to do it. So how does this function behave as a function of E and Y? Okay, so that is to say, here this is I have here X, which depends on Y and E. Question is here, how does my output change if my competitor changes production or if the policymaker increases emissions? Okay, this is something I would like to know. Okay, so if this is, if I can characterize this, then I can also draw a picture. That's something I'm going to do right now. Here are the calculus. Okay, so here, oops, yeah, for both, I have both of these. Okay, so this is, I'm sure you have seen the implicit function theorem in mathematics. Yes, no. You know what the implicit function theorem is? No. Okay. If I have a function that's smooth in, because here you see I have y, that is a, oh, sorry, the opposite. I'm characterizing x, not y. X, that is a function of y and e. Okay, a smooth function. What I would like to do here is I would like to know yes, here I'm not using the implicit function theorem. I'm just taking the derivative. Yeah, it's not necessary to use the implicit function theorem because I'm just doing the yeah, it's not necessary here to invoke the implicit function theorem. Because what I have to do is I have just to take the total differential and rearrange. Okay, so it's not necessary. Because the function is not implicitly defined. Okay, so that's why it's not necessary in this case. So I have just to use the okay. No. Okay. So if the function was like this, then okay, rewind. Okay, because if the function was like this, then I would not have. There was no need for using the implicit function theorem. But the function is not like this. Okay, it's indeed implicitly defined. Okay, like this here. So let me repeat what I have to do. Okay, I have, remember, Rx minus Cx minus Ax equals 0. Okay, so I have implicitly a relationship between x and y. That's why I have to use the implicit function theorem. Okay. Now, what tells me is it clear? I don't have an explicit, because previously I've written it in an explicit way, so that's why there was no need for applying the implicit function theorem. But I have the relationship between x and y implicitly defined. That's why I need to apply the implicit function theorem. Technicality, okay. Nevertheless, what I have to do here is I have to take the total differential. I can do this because the function is smooth. Okay, so I can apply the implicit function theorem if the function is smooth, meaning that the second derivatives are well defined. Then what I can do is I can here take the total differential. What is the total differential? Is I have to see how this relationship here changes if I have a change in x and if I have a change in y. Okay. Then, given that I know how this relationship here behaves as I change x and y, I can establish the relationship between the two. This is the very loosely speaking the implicit function theorem. Okay. So how can I do this, therefore? So how does X affect this relationship? So first of all, I have Rxx dx plus, if I change y, I have Rxy dy, then I have minus Cxx dx, and then I have minus Axx dx. Okay, this is everything that changes if X changes and Y changes. Okay, is it clear? So if X changes, so how does X? If X changes, how does this relationship change? I have Rxx minus Cxx minus Axx, and this changes according to the X. Okay. So how does this relationship change if I have a change in Y? I have Rxy dy, because C and A do not depend on Y. Okay, they only depend on X and E. And then I have to sum these two. I have to sum these two. And so I get this relationship here. Is it clear? And then what I have to do is I have just to rearrange things. Okay, if I rearrange things, I could, yes, if I rearrange things, I sum the two and then set this equal to 0, and then I can calculate therefore how dx over dy looks like. Okay, what it looks like. Okay, is it clear? Okay. So here, notice the following. Okay, so Rxy, this is Rxy is negative. So this is negative. Okay, by assumption. Okay, because we assume that the marginal revenues depend negatively on Y. So this is what I explained before the break. Okay. This is because mainly because of the fact that if my competitor increases the quantity produced, the world price goes down, and therefore I get lower revenues. Okay. And then this term here is also negative. This is negative because of concavity, or put differently, this is positive, this is positive. This is negative, but here I have a negative sign in front, so everything is negative. Okay. So negative over negative becomes positive with a negative sign in front, tells me that this is negative. Okay. So let me. Then I'm going to give you an intuition. Okay. So this is the math, but I'm going to explain you from an economic point of view what's going on. So just a moment. Let me draw this. Okay. So what does this tell us? It tells us that if so let's hear why this is the production of my competitor. This is my production, and this tells us that the reaction function. Because remember, this is let me draw them as straight lines, right? Not necessarily straight lines, but just for simplicity's sake. Okay, this is my x equals fye function. Okay, it's negatively slow. It's clearly the inverse of this. Okay, but this is my reaction function. I'm writing it like a reaction function. Okay, so if my competitor produces, this tells me that if my competitor produces y0, then I'm going to produce x0. Okay. Now, you see, the important thing here for the moment being is that this is negatively sloped. And this means that if my competitor decreases production, then I'm going to increase production. Sorry. Okay, so if my competitor decreases production, I'm going to increase production. Now, any ideas why this is the case? From an intuitive point of view, why is it the case that if my competitor decreases production, I'm going to increase production? Let's see how familiar you are with because this is what I'm going to describe here is a duopoly. Let's see how familiar you are with the duopoly. If my competitor decreases production, why I'm going? So my optimal response to my competitor's reduction is to increase output. So why is this an optimal response?
To cover all the demand.
No, demand adjusts through the price. Okay, if my competitor reduces production, then what happens is price is going to increase. So the market always clears because there is a demand function.
If the competitor increases the price of the output, it means he has a lower price, so he sells the same product with a lower price, so he gets a bigger share of the market.
If my competitor increases the output, you mean? Yes, but then in this case, I would reduce. Yeah, you're right. Okay, but still, what I'm looking here is why, in your case, if he increases production, I'm going to reduce production. Or in the case I've depicted here, it's just the opposite. Okay. So why is it the case that if my competitor reduces production, I'm going to increase production? So perhaps you were hinting at in the right direction. Okay, so it's just that I hope I might make myself clear. It's not that if I'm not going to produce more, there is something that's not covered. The market always clears. This was my response. Okay, so it's not that consumers are not happy. The market always clears because we have a continuous demand function. Okay, so if there is just reduced. Like what's happening now with Russia and the Ukrainian war. Okay, so we know that in Europe we have now a lower supply of gas. Okay, the market clears the price as a consequence. We have higher prices. Okay, but other countries. Okay, as an optimal response should, in this case, and there are many. Okay, if you just look at our policymakers that are hopping around the world with a hat and trying to find some gas supplies. Okay, they find supply. Okay, others are increasing supply. So why is it the case that others are increasing supply? Yes, they profit. They profit on in two ways. Okay, one, by increasing their supply, they benefit because of higher prices. Okay, that's why they can profit by increasing supply. And secondly, if they, in particular, the picture I've drawn here, but this then depends on demand functions, okay? But the picture I've drawn here, you can see if my competitor reduces output by 1, I'm not going to increase output by 1. Okay, this is what I've drawn here. I hope you can see it, okay? So if my competitor decreases output by 1, okay, I'm going to increase output by lower than 1. And why would be this optimal? This might be optimal because I can, by increasing output, still keep prices higher than they were before. Okay, because if my competitor decreases output by 1 and I increase output by 1/2, output will still be lower than it was before, and that's why prices will still be larger than they were before. Okay, you see, that's why for me it's optimal if my competitor decreases output, it's optimal to increase. In the picture I've drawn, and it's true for most, I would say, demand functions, okay? I'm not going to increase output by the same amount that my competitor decreased output. Is it clear why this is optimal? Because in this way, you see, if I increase it, but not by the same amount my competitor decreased output, I can benefit from both of these two effects here. Larger prices, and so larger output and still higher prices. Okay, is it clear? That's why I have this negative relationship, and in particular the situation I've drawn here, that is, in this case, it's steeper than 1. -1 clearly is negative. Is it clear? Now, any questions here? I hope I'm not going too fast. It should be clear. Or something I said something too fast. Just let me know. I can now, before going, I have still to characterize what my FE looks like. So how this reaction function changes if there is a change in emissions. That's something I've not yet done. But before doing so, I would like to. No, let's do it. Yeah, let's do it. Let's do it first, and then I'm going to characterize it. Perhaps it's easier. Okay. Let me go over here again. What I have to do is I have to see how. I have to again apply the implicit function theorem, because this is an implicit relationship here. Again, everything is smooth, so I can do it, and so I just again see how X affects my marginal profits. That would be this part here, and then how E affects my marginal profits. That would be the last term here. And then if I rearrange things, I get this expression here. So this is dx over dE. And now you see this here is negative, so what I said before, and this here is negative as well, because an increase in emissions reduce your margin abatement costs. Okay, remember. So negative over negative becomes positive. Okay, meaning simply that it's quite intuitive. If emissions, if I can emit more, I'm going to produce more. Okay, this is what this states here. So if I can emit more, I'm going to produce more. If I can emit more, I'm going to produce more. And therefore here, this looks like the following. So if I have, this is drawn for, let's say, E0 here. This is drawn for E0. If I have a larger E, so suppose I have, I have an E1 larger than E0, so this shifts my reaction function outwards. Okay, this is drawn here for X equals F Y E1. Okay. This here is for an increase in E. Okay. Okay, now is it clear? You know, so let me see if everything's clear. Make another question. Okay, what is so here, this is my reaction function. So along this reaction function, I can characterize firm profits. Okay, for each, that is to say, for each X and Y, each X and Y, I get firm profits, pi. So I want to know where on these reaction functions profits are largest. Again, this is important for understanding what's happening next. Okay, so where here are my profits largest? So let me rephrase this. Okay, so by moving along this, by moving along the reaction function, my profits change. Okay. So I want to know where are profits larger, if I'm moving towards the bottom here or towards the top. Okay, so where are they larger, here or here? The bottom or the top of the picture? You know the answer, you know what I'm answering. Sure. Why?
You see that y and x are larger amount.
Here, no, y is 0. Here, y is 0. And x has all the markets. So x is a monopolist. And we know that profits are largest in the monopoly case. So here, you have that x is a monopoly. Here you would have y a monopoly. Okay. Is it clear? This is exactly, so if you remember microeconomics, okay, those of you who have taken microeconomics, okay. A monopolist does exactly what we have done here, okay, maximizes profits choosing output. The only difference, there is no competitor because competitor's output is 0. And that's exactly what happens here at the bottom. At the top, the opposite happens. Okay? But in this case, it's why that's I'm choosing output, but I have no market share. Okay, so it's not that's the optimal. Why M is not the optimal choice for my competitor clearly, okay? Because this is what I'm doing, not what my competitor does. Okay, is it clear? Let me erase perhaps this because if it's not 100% clear, this might confuse. Okay, this is because the upper part is not what my competitor chooses, but what happens to me if my competitor is a monopolist. Okay, from my point of view. Okay, so is it clear? So that's why I would like to be as close as possible to XM. Because the closer I move towards XM, the larger are my profits. Is it clear? Okay, so let's see. Now let's see the equilibrium. Okay, let's see the equilibrium, and then I can also discuss the optimal environmental policy here. Okay, let me redraw a figure. Oops. Okay, let's draw here. I should. Okay, I want to draw a symmetric equilibrium. That's why I would like to have the equilibrium at the 45-degree line. So let me draw the 45-degree line. Because I would like to draw a symmetric equilibrium. Okay. This is my x. Oops. X equals FYE. And then I have my competitor, and let me draw my competitor is symmetric. Oops. Okay. more or less be the same. Yeah, I could make better use of the ruler. Okay. And this is why this would be my y equals less energy x. Okay. So the red one is the reaction function of my competitor. The blue one is my reaction function. So the Nash equilibrium is I'm assuming here that they cross just once. Okay. Which is exactly what happens here. Okay, because of the second order assumption, so the derivatives I've just calculated. Okay, that's why this happens here, given the assumptions I've made. This is what's called the Nash equilibrium. Okay, Nash equilibrium is an equilibrium where everybody's happy in the sense that given the actions of my competitor, I have no incentive to deviate, and given my action, my competitor has no incentive to deviate. Okay, that's why this is an equilibrium. Okay. All others, so if I'm not at the Nash equilibrium, all other settings do not satisfy these conditions. Okay, so given what my competitor does, I could change and improve my profits. Okay, so the only thing in the Nash equilibrium, no firm can increase profits, okay, acting individually. Okay. Everybody clear here? What the Nash equilibrium looks like? If something is not clear, just let me know. Okay? If you've never seen this picture, just let me know. Okay, now. Okay, this is for the Nash equilibrium. Now, what if there are no questions, what I can now do is solve the first stage game. Because remember, in the first stage, the policymaker has to choose emissions. So has to choose the cap. Okay, so you can think about it in terms of the EU. It has to choose the optimal amount of allowances. Okay, and knowing that allowances will affect firm costs, and firm costs affect firm competitiveness. Now, the EU can act either strategically, so taking this into account, or non-strategically. Who cares? Okay, so they know that it will affect firm costs and their competitiveness, but who cares? And they won't take into account. That's why we are going to study both the myopic and the non-myopic, the strategic choice. Okay, clearly, the strategic choice is the more interesting case, and that's what we are going to. That's what I'm going to do also here on the figure here on the right-hand side. So let's consider the strategic choice, because I have already the picture here, okay? And then I'm going to show you the non-strategic choice. So what is the strategic choice? The strategic choice you see is choosing emissions, knowing that the choice of emissions will affect firm competitiveness. Okay? Therefore, what should the policymaker do, okay, in this case? By the way, this is if the policymaker chooses in the first stage emissions strategically, then this is called the equilibrium I'm going to calculate is called a subgame perfect equilibrium. I don't know, for those of you who have taken some microeconomics, they probably know this already. Okay, so subgame perfect equilibrium means that I have Nash equilibrium in all the subgames I have. Here I have two games. Okay, I have the overall game and the game in the first stage. And the subgame for perfect Nash equilibrium is a Nash equilibrium in all of its games. So that's why I'm going first to solve the second stage and then solve the first stage, knowing that the solution in the first stage affects the second stage. Okay, this is a perfection of the Nash equilibrium, and it's called the subgame perfect Nash equilibrium because it's what I'm going to look for is a Nash equilibrium in all the subgames. Okay, I have the global game, the game, and the subgame in the first stage. Okay, so this is therefore called subgame perfect Nash equilibrium. Technically, it's not that important, but just for those of you who are familiar with this type of games, okay, they will recognize this. But let's see how emissions, that's more important from an economic point of view. Let's see how emissions affect behavior of firms. Okay, here. Consider now again the home country, because I'm only interested first in the first place in the home country, because then the foreign country will behave in a similar way. Okay, now if I change emissions, okay, here we have seen how this is going to change my reaction function. Okay, so if I change emissions, okay, I know that my reaction function either goes, if I increase emissions, my reaction function goes to the right-hand side, it moves to the right-hand side. If I decrease emissions, then my reaction function goes to the left-hand side. Now, how should if the interest of the policymaker is in the country's welfare, okay, in which direction should I go with emissions? Assuming that this is suboptimal, okay, for the moment. So what should I do? Where should I move with emissions? Should I move towards the right or should I move towards the left? Left. Why should I move towards the left? So you're suggesting I should move in this direction. So let me draw this, and I'm going to see whether everybody agrees. Yeah. Okay, you should, in this case, you go, oops. I have, so what is your Nash equilibrium in this case, assuming that the other firm does not, so the other country does not change emissions? The Nash equilibrium is here, right? This will be my new Nash equilibrium. And E prime with emissions here, E prime lower than E. Okay, everybody agrees with the picture at least I've drawn. Now, I would like, is this optimal if my first interest is firm profits, or is it not optimal?
The core is firm profits, damages for firm profits.
Sorry, can you repeat it? Unfortunately.
It's mentioned maybe damages firm profits.
Yes. Yes.
There are some goods that are not, there's everything else. There are some goods that are not traded because of the cap.
There are goods that are not traded because of the cap. So I did. Yes, in this case I have lower production, lower overproduction. That's what you mean. Yes. Yes. Okay. Let's wrap things up. Okay. So if my interest is foremost in firm profits, this is not a good choice. Okay. Because you see what happens here, as I said before, the bliss point. This is called the bliss point. So where I'm a monopolist, where my firm profits are largest, is always here on the bottom. And you see, therefore, what I would like to do is I would like to get as close as possible to the bliss point. Here, if I'm moving to the left, you see I get farther away from the bliss point. So you see here the distance here, this one here is larger than this here. Okay, can you see this? That's why my firm profits go down. Okay, because I'm farther away. Okay, so that's why moving towards the left is not optimal. Okay, I should move towards the right. Okay, if I'm focusing first of all on my firm profits. Okay, that's why let me. Okay, so what I should do therefore is, you see, I know that by slightly increasing emissions, I can improve firm profits. Okay. So that's why I have to move. Towards the. I would like to move towards the right. Yeah, it's not parallel, but okay. Okay, so. And this is done by increasing emission, because in this case, you see my Nash equilibrium is here, and here I have a lower distance to my bliss point. Okay, so here I'm increasing firm profits. Okay, this is therefore intuitive. So in this way, I have intuitively explained why the country should increase emissions. Okay. Now let me intuitively explain also what the end of the story is, and then I'm going to show you the difference between the myopic and the non-myopic one. But this game is a symmetric game. So if one country decides to increase emissions because it wants to give, as we've seen here, the firm a comparative advantage, because here we are going to give the firm a comparative advantage, because by increasing emissions, our firm has lower production costs and therefore has a comparative advantage. But the other country will do exactly the same. And so you see, if the other country does exactly the same, we have that nothing happens in terms of distance to the comparative advantage. Firm profits decline because they have now they produce more, and therefore the overall price will be lower, and therefore firm profits will go down for both. And so nothing happens in terms of comparative advantage, because we are still on the 45-degree line. Okay. But overall, what happens is that the environment will be much worse off. Okay? And this is called the race to the bottom. Okay. So all countries try to reduce environmental standards by increasing emissions. Okay? By increasing emissions, this does then, at the end of the day, not affect comparative advantage. It reduces firm profits because competition gets stronger, prices goes down. Indeed, you see the distance here increases, okay, for both. That's why you have the firm profits will be lower. And the environment will be worse off. Okay, so overall, this is the increasing emission standard is worst policy. Okay, if you do not take into account the benefit that consumers get from lower prices. Okay, that's why we had consumers placed in another country, because clearly, in this case, competition gets tougher, prices get lower, and therefore, on the one side, consumers benefit from lower prices, but on the other side, they are worse off because the environment is more polluted. Okay, so in the real world, you should really trade off these two. Okay, that's something that we do not want to do here. That's why consumers are placed in a third country, and that's why you only focus on profits and damage done to the environment. Okay, here the result is clear cut. Profits are lower, and the environment is more polluted. Okay, so the last thing I would like to do is are the questions intuitively. Intuitively, everything clear. So the last thing I would like to do is characterize the first order condition and explain why, and it's quite clear, I guess. If you behave strategically, then what you do is you pollute the environment even more than if you do not behave strategically. Okay. Okay, let's see how this is done. Okay, so that's why now I'm going to solve this formally, considering both the government that behaves strategically and non-strategically. So non-strategically would be myopic. I choose today emissions not anticipating what the effects will be on the competition game in the second stage. While in the case of strategic behavior, I anticipate what the effects will be on the competition game when I choose emissions. And this second case here gives rise to the subgame perfect Nash equilibrium I've described before. Okay, so what the government here has to do is the following, is to maximize net benefits here. There will be firm profits minus damage done to the environment. Okay, these are clearly monetary. So in monetary terms, okay, because otherwise this equation would not make sense. Okay, so here because revenues are in money terms, okay, so real terms or whatever, and I need the same unit of measure also for damages. Okay, so they have to be the same. So I need this to be a coherent measure. Okay. And therefore I have to choose E now either myopically or forward-looking. Okay, so let's start with the non-strategic choice. Okay, so the government chooses E in a non-strategic way, so non-anticipating what the effects of E will be in terms of the competition game in the second stage. So therefore here you see, let me repeat this here. Okay, so this will be here profit. Sorry, yeah, let me write it explicitly. Are x, y, minus cx minus ax e and minus e. Okay, this is what I would like to maximize. Okay, these are my net benefits. What I've called net benefits, which depend on they depend on E, and here government chooses E non-strategically, and so it takes only direct effects into account. So how E affects marginal abatement costs and the marginal damage done to the environment. Okay, so these are these two. Okay, so therefore, what are these two intuitively? Okay, so this first here are if I increase emissions, I reduce abatement costs, that is production costs of the firm. Okay, so abatement costs. These are benefits. So marginal benefits clearly. This here, here clearly with the minus in front. This here are marginal costs. Because if I increase emissions, I pollute more the environment, and this increases damages done, therefore, to the environment. Okay, and therefore, what I have to do is I have to optimally trade off marginal benefits and marginal costs. Okay, so at equilibrium, what you would like to do is you would equalize marginal benefits and marginal costs. Okay, these are marginal benefits of increasing E. These are marginal costs of increasing E. Okay, this if the government does not behave strategically. Now, given all the second order conditions I have that the marginal net benefits are decreasing in E, and therefore this is my optimal level of emissions. Okay, represented graphically. Okay, everything clear? Now, what changes if the government behaves strategically? If the government behaves strategically, let me write this here. Okay, this would be pi. Here in this case, I have pi x. Now let's write it in this way. Rx y minus Cx minus Ax E minus DE. Okay, so these are my profits. Okay, now if the government maximizes now these net benefits, if you remember, these are net benefits. Okay, these are my oops. These are my net benefits, but maximizes now net benefits choosing E in a strategic way. Then I have, okay, first of all, how E affects X and how X affects my profits. Then how E affects X, how X affects Y, and how Y affects profits. And then I have the direct effect. Okay, so this is my direct effect. And this here is the indirect effect. Okay. Is it clear? So let me repeat this. The first term is how E affects X, how X affects my profits, how E affects X, but then X affects Y. Okay, this is the strategic effect, and how Y affects my profit. And then I have just how E directly affects net benefits, okay, through reducing my margin a bit, through reducing abatement costs and reducing the environmental damages. Increasing, sorry, environmental damages if I increase speed. Okay, now note the following. Note that, again, this is just a result of the envelopes here, and we have seen last week. Pi x equals 0 because firms maximize profits. So this term here disappears because firms maximize profits. Okay, they choose X, maximizing profits. That's why pi x equals 0 because of the first order condition. And then, so the only thing that remains is this second term and the third term here. Now, what about this second term? Remember, this is how E affects X, how X affects Y, and how Y affects pi. But also remember that pi Y is negative because if my competitor increases production, world prices go down and my profits go down. Okay, so if Y increases, price goes down and profits go down. That's why I have PY negative, PY negative. Okay, then I have also that this is negative because this is what we have already seen before. So the picture I've drawn, remember that my reaction functions are negatively sloped. Okay, so this is therefore negative times negative is positive, and XE was positive. This is something that we've seen above. Okay, so if I increase E, output increases. Okay, remember from the picture I've seen here. If E increases, output increases. That's quite intuitive. The more I can emit, the more I will produce. Okay, that's what this time. That's why this here is a positive term. Okay, so if I would like to draw this picture, okay, you see, I have now this red one was the one we had if government behaves in a non-strategic way. This green one here, if the government behaves in a strategic way. That's why you see here, this is non-strategic. This is here, therefore, the optimal emission if behaves strategically. Okay, that's why here you see if government behaves in a strategic way, what they do is they increase emission standard. Okay, so sorry, the increase standard would be kind of reduction. They increase the emission permits. they increase the emission permits. So, okay, they increase the emission permits compared with the non-strategic case. Okay, is it clear? So that is to say, taking into account how my action as a government will affect competitive advantage of my firm, I will let firms pollute more. Okay? Because I would like to give my firms a competitive advantage. That's why I'm going to allow firms to pollute more. Okay? Emissions affect the competition game. Okay? Since by increasing emissions, I can give my firms a competitive advantage, I will do so. Okay? That's why I'll allow firms to pollute more. Okay, this is the difference between the two. In the first, I do not take this competitive advantage into account. So the fact that by increasing emissions, I give my firms competitive advantage. This is here in the first case here, the red one. In the green one, I take into account that by increasing emissions, firms get a competitive advantage. And that's why I will do so and increase emissions. Okay. So notice that the non-strategic case is important because this is what policymakers should do if we eliminate the strategic interaction. So just looking at damages and costs and trading off damages and costs. Okay. So I would like to reduce emissions in an optimal way. That is, I balance therefore here damages done to the environment and damages done to the firm. This is the red one. But I'm not taking into account damages done to the firm in terms of comparative advantage. Because if I take into account also the damages done in terms of comparative advantage, then I pollute too much. Okay. So international environmental agreements should lead to the red one, okay, not to the green one. Because in the green one, you see I have strategic interaction where everybody competes for market shares. Okay. So I'm reducing environmental regulation because I want to attract firms, I want to attract business. Okay, I want to give my firms a competitive advantage. And therefore, we need international environmental agreements because in this way, I have the red one, where I only take into account direct effects on the firms and direct effects on the environment. And not the fact that the competitive advantage changes. Is it clear the difference between the green and the red one? So let me repeat, in the green one, I have the competitive advantage. So that is to say, government takes into account that environmental policy affects competitive advantage. In the red one, I do not have this comparative advantage effect. Okay. Therefore, I need international environmental agreements so that I can have the red equilibrium rather than the green equilibrium. Okay. Because what happens in the Nash equilibrium is what we've seen on the other picture I've drawn on the notes. Okay. If everybody behaves strategically, then we have lower firm profits because firm produce more, price will be lower, and higher pollution. So it's just everybody loses, okay, from such a strategic gain, okay, because everybody increases emissions, so everybody will be worse off. Okay, that's why we need environmental agreement. This is kind of a prisoner's dilemma. Okay, this is what you have seen in the first part. So there's a prisoner dilemma. Everybody, individually taking, everybody would like to increase emissions, hoping that the other country does not do so, but then clearly everybody behaves symmetrically, and so we'll end up in the worst case scenario. and that's the prisoner dilemma. Okay. Okay, I guess I'll stop here because this is then things that you have already discussed at length in the first part of the course. Okay, if there are no questions, everything is clear. I would like to stop here, and then starting tomorrow, we'll deal with the optimal and efficient use of non-renewable resources, okay, and the issue of sustainability. By the way, I try to stress tomorrow, okay, that the two are different issues, okay, sustainability on the one side, and the optimal and efficient use of non-renewable resources. Okay, there are two different issues. Okay, and I will also show one point formally. Okay, will be very boring with boring math. That I give you a very simple example that sustainability might not be socially optimal. Okay, sustainability might be desirable, but something that's not socially optimal. Okay, and we need conditions, okay, such that sustainability is something that countries really aim to obtain. Okay, otherwise it's not socially optimal. Okay, therefore I'll discuss what the optimal and efficient use of non-renewable resources is, what the issue of sustainability is, and how they might not be aligned. Okay, there are two different things, and they might not be optimal to pursue sustainability. Okay, so thanks for the moment being. Have a nice evening, and talk to you if you want tomorrow. Okay.
Thank you.
Bye bye. Thank you. Thank you very much for that. Bye bye. I was at home. Great. Great. Great.